the Cox-Proportional hazards model. So Cox regression now. So I told that Cox regression solves some of the limitations of the Kaplan-Meier curve. So the Cox regression is a semi-parametric regression method for survival data, and it's mostly used for multivariable survival method to estimate the effects of covariates on the hazard. So we're trying to estimate the effect of covariate on the hazard, and we have no assumption about the baseline hazard shape. It has no assumption about baseline hazard shape, and also can include multiple predictors. You can have various predictors, as much as 10, 20, and it can handle both continuous and categorical variables well. So which means if your predictors are actually combination of categorical and continuous, the Cox regression can handle it well for you. So we have this formula. You can see it's similar to the regression formula except for this particular exponential, and instead of the intercept, we're having the baseline hazard multiplied by the exponential of the coefficients with their predictors. So where this is the hazard at time t, given this particular covariate, we have the baseline hazard, the regression coefficients, and we also have the covariate values. So the hazard is usually the product of the baseline hazard and exponential function of covariates. So why do we have proportional hazard? So the proportional hazard assumption says that the hazard ratio between any two individuals is usually constant over time. So the hazard ratio between any two individuals is constant over time. So for two subjects with covariate values x1 and x2, then the hazard ratio is going to be constant over time, and this ratio doesn't depend on time t. The prediction means that effects are usually multiplicative on hazard scale. So instead of being additive, this effect is usually multiplicative on hazard scale. So how do you interpret this Cox coefficient? So the coefficient beta usually represents the log hazard ratio per unit increase in covariate, and the positive beta usually represents the increased hazard or worse survival, while the negative beta usually represents the decreased hazard better survival. So if you notice in regression too, also if you have a positive coefficient, increase prediction, it causes a unit increase, while a negative coefficient causes a unit decrease. So in terms of the Cox coefficients, a positive beta means an increased hazard, a negative beta means a decreased hazard. When you have your beta coefficient to be 0, it means there is no effect. So coefficients are on a log scale, so we exponentiate to get the hazard ratios. So this is an example. Now you can see our coefficients here. So hazard ratio from the multivariable Cox model. So this is a forest plot, and you can see anywhere you see hazard ratio of 1, it means that that particular covariate is not significant. And you can even see that from the p-values here. The p-value is on the right hand side of the line, or the dashed line. So you can see the p-values here. So when you see the p-value, then you can know that that particular value is not significant. But if you see it on the left hand side or the right hand side of this one, it means that particular covariate is significant. So for the first one, we're having a coefficient of 1.01, which means what? No effect. Then we're having also sex. So this is the reference value. So this particular sex that you're looking at is actually the reference. So we're going to be, because this age is continuous, but this sex is categorical. So this is the reference. We're going to be interpreting it based on the other level, which is the female. So this particular female level under the sex covariate is significant. And you can see it's on the left hand side, which is 0.56. So which means that what? The hazard of experiencing or dying from lung cancer is 0.56 less than that of male compared to the male. So that's a 0.56 hazard ratio of experiencing lung cancer compared to male. So pH.ECOG is actually more or less like the performance status. So of this actually continuous variable. So you can see it's significant, which means that what? Those with a higher pH ECOG have a higher hazard of 1.88 of experiencing lung cancer compared with those with a lower pH ECOG. Now we also have the pH.Kano, though this is not actually significant. So this is just how you can interpret your Cox coefficients. So categorical predictors. So categorical predictors, you usually have one category is the reference, which I've already showed you earlier on, while you compare the other categories hazard ratio with the reference category. And we also have treatment A versus B too also. Or you can have A, B, and C, whereby A is going to be the reference. You compare B to A. You also compare C to A. And for continuous predictors, the hazard ratio actually increases as with an increase in that particular continuous predictor. So for example, an increase in age, when you have a hazard ratio of 1.6, it means what? For an increase in age, the hazard ratio is going to what? Increase by 1.6. And usually assumes a linear relationship with a log hazard. And you can also transform it if it's needed, and you can categorize it, but you lose much information if you categorize a continuous predictor. So for example, now if you have age coefficient of 0.05, it means the hazard increase 5% per year of age. So your age coefficient means that the hazard is going to increase 5% for each increase in year. So Cox model can usually include various predictors simultaneously, just as I've already shown you. It controls for confounding and also identify independent predictors, and it's more efficient use of data, and also test interactions. And it also tests for interactions, just like I've already explained in regression. You can also test for interaction inside a Cox predictor model. So consideration usually need adequate sample sizes. You have to have a lot of sufficient sample size, events, not just subjects. So we're talking of events now. Your sample size of events should be much, not just subjects. So in terms of sample size, we're talking of events. Your events should be sufficient enough. So rule of thumb, should always have greater than or equal to 10 events per predictor variable. So what 10 events per predictor variable means that you should have at least 10 occurrences of the outcome for every variable in your model to get reliable and stable estimates. So you should have 10 occurrences of the outcome for every variable in your model. So for example, now you have age, you have sex, you have pH.epoch. So each of these particular variable, at least you should be able to have 10 outcome from each of these particular variables that you have. So what are the model building strategy for Cox regression model? So you have univariable screening. You can test each predictor separately and identify candidates using p less than 0.2 or clinical importance. So we use the p less than 0.2 just to be lenient, to identify just possible candidates and put them inside our model. So multivariable model will include candidate predictors, and you check proportional hazard assumption and also consider interactions. So more multivariable model, you include candidate predictors, you check proportional hazards assumption and also consider interactions. It's part of some of your model building strategy. So third is model reduction. You should remove non-significant predictors. So after testing multiple predictors, you remove the non-significant ones and you compared them with each other, and also compared nested models with likelihood ratio tests. So time-dependent covariance. The standard Cox model, covariance usually measured at baseline. So, and for time-dependent covariance, values usually change during follow-up. So, for example, now transplant status, we have waiting versus transplanted. You can see that these are time-dependent covariance. Also have disease status, remission versus relapse. This is also a time-dependent covariance. Also have medication changes. So, time-dependent covariance usually requires special coding and extended Cox model formulation. Stratify Cox model. So when proportional hazard assumptions fail for a variable, you have to stratify for that particular variable. So this allows different baseline hazard per stratum and estimates common effects. So this is more or less like a multi-level Cox model you're trying to do, and also does not estimate the effect of the stratification variable. So it's stratified by hospital and also the estimate treatment effect. So what are the assumptions of the Cox model that should be met? So first of all, you have the hazard ratio have to be constant over time as usual. You also have to have a linear relationship, or your log hazard should be linear with the continuous predictor. So the log of your hazard should be linear with the continuous predictor, and also the independence of observations. They should be independent from each other, and you also have appropriate transformations where possible. So already know that the proportional hazard is the hazard ratio between two groups that is constant over time. So whereas one group always have twice the risk of the event compared to another group, no matter the amount of time that has already passed. How do you check for proportional hazard? So you need to check for it because that's where you handle proportional hazards. You either use the graphical method or use the statistical methods. If the proportional hazard is actually violated, then you stratify on that particular variable, or you include time interaction, or use a time varying coefficient model. So what are the advantages of the Cox model? It is parametric, which makes it very flexible for baseline hazard. It's actually robust, handles various distributions, controls for confounding, and also it uses all available data. It's also interpretable through the hazard ratios and is widely accepted in medical research. But it has some limitations, such as proportional hazards may not always hold is one of the assumptions of Cox model. Complexity has more assumptions than the Kaplan-Meier, and it also needs adequate events. When we talk of sample size in Cox model, we are talking of adequate events, not adequate number of subjects or observations. Also, non-linearity at times, it may need transformation for you to obey the assumption of linearity, and also only relative comparisons, no absolute risks, and also competing risks need special handling.